If I say the word acid, most students immediately think they know what it means. That confidence is exactly the problem. In organic chemistry, the word acid stays the same, but its meaning quietly changes. And if you don't notice that change, organic chemistry will never feel logical. Students don't fail organic chemistry because it's reaction heavy. They fail because they carry aqueous acid based thinking into a non aqueous world. Let me be very, very clear to you. Generally, you know, let's take an, basically a very good example to understand the concept of an acid. Imagine hydrogen is money. Some molecules give it away very easily, and some hold it very tightly. The acid base chemistry is about who is generous and who is greedy. Acids give protons, means H plus, and bases takes H plus. This definition works only in water. That is the problem. That is why I earlier said that students generally carry these definitions into the non aqueous world. But organic chemistry doesn't care about definitions, it cares about stability after proton loss. Now, let's understand acids and base concept more deeply. See, suppose if I simply write it down, HA denotes acid, whereas let's say B negative denotes base. Now, what happens if an acid loses a proton? If it loses H plus, it will form A negative. And now this A negative is called as its conjugate base. This is called as its conjugate base. Whereas B negative is a base, but after gaining an hydrogen, it forms HB, which is its conjugate acid. Now, these two new terms are basically introduced. One is conjugate base, one is conjugate acid. Let me revise this very quickly to you. Suppose any acid, if it loses a proton, whatever species it is going to form, that is going to be called as a conjugate base. And if a base accepts a proton, it will form a conjugate acid. In short, every acid creates a base, and every base comes from an acid. That's a key line here. All right. And what is the key point? What is the important point that understands, basically, that gives us a very, very good understanding about this concept is acids don't decide to lose proton. They lose it if what's left is comfortable. They lose it if what's left is stable. In short, an organic acid is not defined by given H plus. It is defined by what remains after H plus is gone. That means the acidity is much more defined with their stability. We are much more concerned basically about their stability. If I talk about only acids, we are much more basically concerned about its stability. Because what is left after losing H plus, whether it is stable or not, whether it is comfortable or not, that is a bigger question here. And that is what is going to tell us whether something is acidic or whether something is not acidic. Let me take an example for you to understand it more clearly. Suppose we have hydrochloric acid, HCl. What I just told you, an acid loses a proton. If it loses a proton, means H plus, guys, it will form Cl negative. On the same hand, let's say if I take example of methane, after losing a proton, it will form H plus and CH3 negative. Now, let's check it out the stability of this species, which is called as conjugate base, because this is what decides the acidity. Because it will actually tells us whether something is acidic or not. Because acidity is not always about giving the H plus ions. It is always about what is left, what is going to form after losing H plus ions. That is, we are going to see the stability of conjugate base. Now you can see here, Cl negative is much more stable because negative charge on electronegative species is always better stabilized. And if this is stable, guys, it means HCl is a strong acid. On the same hand, methyl negative is unstable because carbon containing negative charge are generally unstable. They are not very much stabilized because of the lesser electronegativity of carbon. That means if methyl negative is unstable, then this methane is a very weak acid. That's a very, very good example to understand what do we mean by acidity. Sometimes in organic chemistry, we are very much obsessed with the numbers, with the pKa values, with the Ka values. But the reality is, we just need to know who is stronger. That's all. Values comes later. First of all, we should actually differentiate them on the basis of their strength of acidity. And that strength will be determined on the basis of stability of conjugate base. All right, right. Let's take one more example. Let me test your instinct now. Who is more acidic between methanol and acetic acid? What will be your answer? Most students answer this correctly, but for the wrong reason. They don't know what is exactly the reason behind it. What is exactly the reason behind it? They don't know about this. Generally, students say carboxylic acid is acidic because it is a carboxylic acid. Yes, carboxylic acid is more acidic, but this sentence is just meaningless. Just because acid is written as a suffix, that means it is acidic. No, that is not the exact reason behind that. Let us form their conjugate bases. Now, here comes the important part. Here comes the real explanation behind the acidity. Because when it loses the H plus ions, guys, it will form methoxide ion CH3O negative. Whereas when acetic acid loses a proton, this will form CH3COO negative, acetate ion. Now, let's compare the conjugate bases. Let's compare the conjugate bases. Guys, who is more stable according to you? Tell me. You know, in the methoxide ion, guys, this negative charge is localized. Whereas in the acetate ion, this negative charge is delocalized. Means, look at that. This negative charge is delocalized. And when the negative charge is delocalized, That means this negative is much more stable. These are the keywords here. Negative charge is delocalized. And that simply tells us who is more acidic. It takes just a second now to tell us why acetic acid is more acidic than the methanol. Both can lose protons. That is not an issue. But the problem is, the issue is who loses H plus more readily, more easily. The answer is acetic acid. Because after losing a proton, after losing H plus ion, its conjugate base is much more stable. It is delocalized. This single observation decides acidity, not the name, not the functional group, not even the definition. It is just a simple concept. AP, DAT, and MCAT exploit this mistake mercilessly. So what happens here is, we know this. What happens here basically is, in AP exam, it involves the same concept, but every time they gives us a new molecule, and it checks us basically our basic understandings of the concepts of the subject. Whereas in the DAT exam, we need to make fast decisions. There is no time to think there. And of course, in the MCAT, we have to see the applications of acidity basicity inside the biology. If your thinking begins with definitions, these exams will always feel unpredictable. They are not unpredictable. Your thinking order is. Okay? So the concept is very simple. What we learned today is again a very simple concept, that is, acidity is decided. Acidity is decided after H plus is lost. Means whatever is remained after losing H plus ion, guys, acidity will be decided with the help of that thing only. Means whether that thing is stable or not, whether the conjugate base, the resultant conjugate base is stable or not. The guys, acidity will be decided on that thing only. All right. All right. So organic chemistry is backwards compared to general chemistry. It judges what survives, not what reacts. If organic chemistry feels like memorization, you're asking questions in a wrong order, fixed order, and the subject slows down. Thank you so much.